Hi, I'm Viva Press, and in this presentation, I will describe how humorous robotic behavior may act as a new approach to mitigating social awkwardness. I'd like you to imagine riding in an elevator, or attending an academic conference, or maybe you're at a networking event. For some of us, it is natural to strike up conversation, and for others, the potential social awkwardness of a situation is enough to cause us to avoid interacting in the first place. Even though research has shown that social interactions are good for our health, many people will not initiate conversation out of fear of awkwardness. Some approaches being used to reduce awkwardness in social interactions include team building activities, digital games, and mobile games, which can create comfortable, playful ways for participants to get to know each other, but can also hinder natural conversations, take time, and involve an added activity. Another topic of research looks at technologies that support human-human interaction. Robots specifically are being deployed into our lives, and studies have shown that people automatically interpret the autonomous behavior of robots as social cues and see them as relevant for a social context. This makes it easy to integrate robotic objects into social interactions, and it gives them the potential to impact how people interact with one another. Raffinsky and colleagues showed that even simple non-humanoid robotic objects peripheral to an interaction and using gestures as a communication mechanism can influence the quality of a human-human interaction. It is also known that humor has many benefits. Humor can act as an external cue to prompt positive feelings and shift perspective, and can help people in small groups engage in smooth social interactions. So it's not a surprise then that humor is being tested in HCI and HRI research for better communication and to make human interaction with technology more likable and fun. Our idea combines this related work and takes it a step forward to test robotic humor in human-human technology interaction. We set out to evaluate whether a humorous non-humanoid robot can serve as a novel approach to mitigating social awkwardness between strangers. Our main contribution is within the field of technologies being designed to support and enhance human-human interaction. We show that when there is a clear need to mitigate awkwardness, a robotic object performing humorous gestures can encourage strangers to initiate conversation with one another without adding additional time-consuming activities and enable a natural interaction flow. We invited 52 participants to the lab and used a between participants experimental design. Participants were randomly assigned to one of two conditions, humorous and non-humorous. We compared the effect of the robotic gestures on the participants' experience of awkwardness between the conditions. In both conditions, the interaction included awkwardness because we were testing whether the robotic behavior could mitigate awkwardness. But let's rewind for a minute. In order to run the evaluation study, we needed a non-humanoid robot that could perform humorous gestures, and we also needed a scenario of social awkwardness. We used an existing non-humanoid low degrees of freedom mechanical object that has no human-like features. It was designed to be peripheral to interactions between humans. That means the robot can be seen, but it is not an equal participant to the interaction. Previous studies indicated that this robot can positively influence interpersonal human interactions. The robot was not designed to be humorous, so we designed humorous movements for it in our 2022 validation study. These gestures incorporate key elements of humor theories, playing with expectations, incongruous exaggerated movement, mix of slow and fast movements, repetitive gestures. It creates a humorous experience based on the essence of its movement. For this study, we generated two animation compilations. We used gestures from the validation study that were perceived as humorous in the experimental condition and gestures from the validation study that were perceived as non-humorous in the baseline condition. The humorous behavior sequence mixes slow and fast movements, and the non-humorous animation sequence consists of very slow movements. We also created a 1-minute breathing-like animation. We ran a pilot study to verify an awkward scenario, placing chairs in violation of a comfortable conversation distance, setting the length of the interaction, and placing the robot at a slight offset to minimize interference in face-to-face communication. We used semi-structured interviews to find out how participants felt during the interaction, and results verified that this setup did indeed lead to a socially awkward interaction. Despite being told that there would be a robot in the room, and despite the robot's close proximity to the participants, the robot did not provide a common ground that diffuses awkwardness. The pilot study and the main study had the same setup, only in the pilot, the robot never moved. Which brings us back to the evaluation study. For the social awkwardness interaction, participants left their phones and smartwatches outside the experiment room so that they would face the situation and not hide behind a screen. We asked them to sit on the chairs and told them that the experiment would begin soon, that they should wait, and then we left the room. They received no other instructions. For the first minute of the experiment, the robot did not move at all. We then activated the robotic object using the Butter Robotics platform to perform a condition-specific animation compilation and slow breathing-like movement, which allowed the interaction to continue to play out naturally while keeping the robotic movement fluent. Our dependent variables included lexical decision, semi-structured interviews, and the Godspeed questionnaire. Lexical decision is a reaction time-based measure. It assesses implicit processes and gives an objective evaluation of social awkwardness after the interaction with the humorous or non-humorous robot. Participants were asked to judge whether a string of letters presented on a computer screen makes a word or a non-word, and tap the key accordingly. To understand the impact of the robot's behavior on participants' awkwardness experience, we used 3 types of words in the task: awkwardness-related words, comfortable-related words, and neutral words. Previous studies showed that people respond faster to words that represent their emotions and slower to words that are irrelevant to their context. So we predicted that when the robot is humorous, people will respond slower to words like hesitant, as opposed to words like relaxed, because they would feel that in the humorous condition, awkwardness-related words were not relevant to how they felt. And so there was a slower reaction time to the awkward-related word, like hesitant, in comparison to neutral or comfortable words. We used a 2-way ANOVA evaluating the interaction between the 2 robotic conditions and word type. Results showed that participants' reaction times to awkwardness-related words varied between conditions, unlike the reaction times to comfortable and neutral words. Post hoc contrasts comparing the reaction times for different word types in the different conditions showed that awkwardness-related words were not relevant to the participants' emotional context in the humorous condition. We also asked participants 8 predefined questions to gauge how they perceived the awkwardness experience, and we used a thematic coding method to analyze the data. For the majority in the humorous condition, the robot had a positive impact on the stranger's interaction, making it more comfortable and less awkward, though a few said the movement commanded their attention away from the conversation. A majority of participants used words such as comfortable, less awkward, curious, and interested when talking about how the robot made them feel in the interaction, but a minority of others used negative words like creep me out. A majority of participants also said the robotic object's role was as an icebreaker, conversation mediator, or entertainer, although some came away with negative roles. One thought it was eavesdropping. Participants in the non-humorous condition reported mixed impact by the robotic object on their interaction. Some said the robot made them feel negative feelings of stress, others said it had a relaxing vibe, and still others didn't feel its presence. Just over half the participants said the robot played a positive role, icebreaker or conversation starter. Some said it interrupted, and some said it didn't really have a role. We also used the Godspeed questionnaire to test participants' impression of the robot. Previous studies showed humor could raise likability of a robot, and our hypothesis was that the humorous movements would improve participant impression of the robot. Instead, we got null results. So what happened? It could be that this situation of awkwardness required heightened attentional resources in order to deal with the awkwardness of the situation, and participants didn't really focus on creating an impression of the robotic object. But this should be further tested in the future. So going back to the beginning, we know that social interactions are good for our health. We know that awkwardness can hinder these social interactions. Our study shows that it is possible that humorous robotic objects can reduce first encounter awkwardness in different contexts. We also provide a further indication that robots have great potential in shaping and enhancing human-human interaction without radically changing the interpersonal relationship, and that a robot performing humorous gestures can foster a positive effect on interpersonal relationships in a context of social awkwardness and keep the social interaction smooth without the need for a new activity. We hope you'll delve deeper into our research paper, and we'd love to answer any questions about this work.